NeuroGov plus AI, Policy Engine and Set Theory. A formal foundation for governed AI management. Role of Set Theory in Brain NeuroGov plus. 1. Brain NeuroGov plus can be envisioned as an AI management and intelligence architecture in which artificial intelligence is not treated as an isolated model, but as part of a structured ecosystem. AI engines provide specialized intelligence, while data points, sources, registers, relationships, DFDs, cockpits, and governance mechanisms provide the surrounding management structure. Within this architecture, a policy engine can provide the governance layer that evaluates AI intelligence against defined policies, conditions, responsibilities, and permitted actions. Set theory can provide a formal way to represent and organize the entities and relationships on which this management process operates. 2. The policy engine has a fundamentally different role from an AI engine. An AI engine may analyze information and produce an intelligence result, while the policy engine evaluates what should happen with that result under defined governance rules. In simplified form, AI asks, what does the information indicate? Policy asks, what may, must, or should be done with that information. This separation creates an important management boundary between intelligence generation and governed action. 3. Set theory provides the formal structure for this policy environment. A set can represent a collection of NeuroGov plus objects such as data points, sources, AI engines, policies, users, domains, actions, or intelligence results. For example, a data point set can represent the information elements required for analysis, while a source set can represent the origins of information. An AI engine set can identify available specialized intelligence capabilities, and a policy set can contain the rules governing their use. This provides a systematic foundation for classification, membership, selection, comparison, and relationship management. 4. One of the most useful applications is set membership and subset analysis. If a particular data point belongs to an approved data point set, the policy engine can recognize it as an eligible information element. Similarly, an AI engine can belong to an approved engine set, or a source can belong to an authorized source set. Subsets can represent specialized categories within larger domains. This allows NeuroGov Plus to distinguish between all available information and information that is relevant, approved, required, restricted, or subject to particular policies. 5. Set operations can also support policy conditions. Intersection can identify situations where multiple conditions occur together. Union can combine multiple categories requiring common treatment. Difference can identify missing, unresolved, excluded, or unreviewed elements. Complement can represent information outside an approved category. For example, if one set represents high-risk cases and another represents AI-identified anomalies, their intersection can identify cases satisfying both conditions. The policy engine can then apply a governance response such as review or escalation. 6. Set theory can also strengthen the relationship between data points and sources. A formal relationship can describe which sources provide which data points, while another relationship can describe which AI engines use particular data elements. Further relationships can connect AI intelligence results to policies and policies to authorized actions. Conceptually, NeuroGov Plus can therefore establish a traceable chain: source rightward arrow, data point rightward arrow, AI engine rightward arrow, intelligence rightward arrow, policy rightward arrow, decision rightward arrow, action. This is particularly valuable for traceability because the system can maintain the relationship between an outcome and the information and intelligence that contributed to it. 7. The combination becomes especially powerful when the policy engine identifies missing or insufficient information. Suppose a policy requires a defined set of data points, but only part of that set is available. Set difference can identify precisely which required elements are missing. Rather than allowing an AI process to operate blindly on incomplete information, the policy engine can require additional information, verification, human review, or another analytical cycle. Thus, set theory is not merely mathematical notation, It can support practical governance decisions concerning data completeness, eligibility, evidence, and controlled processing. 8. The architecture can then connect AI, policy, and human decision-making into three complementary layers. The AI layer provides analysis, pattern recognition, classification, prediction, or other specialized intelligence. The policy engine evaluates that intelligence against applicable policies, context, risk conditions, permissions, and responsibilities. The cockpit or responsible human then receives the governed result for review, authorization, escalation, or decision where appropriate. The resulting principle is, AI provides intelligence, policy provides governance, human expertise provides judgment and responsibility. 9. This gives Brain NeuroGov Plus a potentially powerful common management concept across financial, business, governmental, enterprise, analytical, operational, and other specialized domains. The domain-specific data points, sources, AI engines, policies, registers, and cockpits can change, while the underlying management architecture remains common. Set theory can provide a formal language for representing these changing sets and relationships, while the policy engine provides the operational governance layer. In this way, AI plus policy engine plus set theory can become an important architectural extension of the NeuroGov plus philosophy, human plus AI plus governance working together rather than human versus AI. Summary. The role of set theory in Brain NeuroGov Plus is to provide a formal method for representing and managing the architectural objects and relationships that support AI governance. It can help represent data points, sources, registers, AI engines, policies, domains, intelligence results, users/authorities, actions, relationships. The policy engine then uses these structured elements to evaluate AI results against defined governance requirements. The conceptual flow becomes data rightward arrow set / relationship structure rightward arrow AI engine rightward arrow intelligence rightward arrow policy engine rightward arrow governance rightward arrow human decision rightward arrow action. Power summary. Brain NeuroGov plus AI plus policy engine plus set theory. AI provides intelligence. Set theory provides formal structure. The policy engine provides governance. The cockpit provides human interaction. Human expertise provides judgment and responsibility. Therefore, AI plus set theory plus policy engine. Downward arrow. Governed AI intelligence. Downward arrow. Human plus AI plus governance. And the broader NeuroGov plus philosophy becomes: the future is not human versus AI, the future can be human plus AI plus governance. This positions the policy engine and set theory as management and governance layers around AI, rather than replacing or altering the specialized AI engine architecture. Example: PPC in a manufacturing unit. Suppose a factory manufactures 100 units of product A. 1 data points. PPC collects. Customer order equals 100 units. Required delivery equals 10 days. Raw material available equals 80 units. Machine capacity equals 120 units. Available manpower equals 90%. Current production equals 70 units. Defect rate equals 5%. These become structured data points. 2 sources. The data may come from sales order rightward arrow ERP rightward arrow inventory rightward arrow production machine rightward arrow quality system rightward arrow HR. So NeuroGov Plus can establish data point rightward arrow source. For example, machine capacity rightward arrow production planning system. 3 AI engine. A specialized AI/PPC engine analyzes the information and identifies potential shortfall of 20 units before the delivery date. AI can examine production capacity, material availability, historical production performance, and other relevant information. 4 Policy engine. Now the policy engine evaluates the AI result. Example: policy. If projected production is below the customer requirement, initiate PPC review. The policy engine therefore does not simply accept the AI recommendation. It checks the result against the defined PPC policy. 5. Set theory. We can represent the situation using sets. Let O equals 100, O equals \100 \. Represent the required order quantity. Let P equals 80, P equals \80 \. Represent the currently achievable quantity based on the identified constraint. Then OP equals 20, OP equals \20 \. The difference identifies the 20-unit production gap. Another example. M equals available materials, M equals \text available materials R equals required materials R equals \text required materials. If RM is not equal to RM \NUC empty set, then some required materials are missing. That becomes a useful PPC governance condition. 6. Policy decision. The policy engine could produce AI result, production shortfall detected. Downward arrow. Policy, shortfall requires PPC review. Downward arrow. Governance status, review required. Downward arrow. PPC cockpit, manager receives alert. Downward arrow. Human decision, arrange additional material / overtime / rescheduling. 7. NeuroGov plus flow. Customer order. Downward arrow. Data points. Downward arrow. Sources. Downward arrow. PPC AI engine. Downward arrow. AI analysis. Downward arrow. Set / relationship analysis. Downward arrow. Policy engine. Downward arrow. Governance decision. Downward arrow. PPC cockpit. Downward arrow. Human decision. Downward arrow. Production action. The important point. The AI does not independently decide to change production. Instead, AI identifies intelligence. Rightward arrow. Set theory structures the conditions. Rightward arrow. Policy engine governs the response. Rightward arrow. Human PPC manager makes the appropriate decision. This is a very good small example of your broader human plus AI plus governance philosophy applied to a real manufacturing PPC environment. About Dr. Pradeep K. Suri. Dr. Pradeep K. Suri is the inventor and architect of Brain NeuroGov Plus. His approach brings together long-standing concepts of systems analysis, structured analysis, information flow modeling, data management, AI, and governance into a modern AI management and intelligence architecture. The NeuroGov Plus philosophy moves beyond viewing AI as simply an individual model or application. It treats AI as part of a structured ecosystem in which data points, sources, registers, relationships, DFDs, specialized AI engines, policy engines, governance mechanisms, cockpits, and human decision-making can operate within a connected and traceable architecture. The introduction of set theory and a policy engine provides a further formal and governance-oriented perspective. Sets organize the information and entities, relationships connect them, AI generates intelligence, policy governs its use, and humans retain appropriate judgment and responsibility. Dr. Pradeep K. Suri. Inventor and architect Brain NeuroGov Plus. Brain NeuroGov Plus AI management for a positive human future. Thank you for watching the video.